Hello students, welcome back. Uh, in this class, we are going to deal with the next type of a data structure, that is the implementation of stack using Java. So in the last class, we have basically discussed about the implementation of linked list data structure and how to perform the different operation onto the linked list, right? So in this class, we are basically going to discuss the different types of the operation uh, which we are going to carry it out onto the stack data structure and how to use the Java in order to implement this operation onto the stack. So very first, in this class, we'll see that what is a stack. So all we have heard about the term that is a stack, right? Whenever we are framing or we are just putting something one on another, so that is basically the stack structure for you. So for example, when you are talking about when we are placing the CDs one over another, so that is what basically one of the stack, right? In which what whichever element we are inserting at the first, that will be get out, that is at the end, or whichever element we are going to put up at the last will be going to out first. So that is what the stack for you, right? And when you are talking about a stack as a data structure, so it is basically linear data structure in which the operations which we carried out, that is the last in first out, right? So whenever we are having a last in first out operation or first in last out operation, that is the stack for you. And when you're talking about a stack, so on the stack, we are basically performing the two important operation. The very first is pushing operation, that whenever we are inserting or adding the new elements into the stack, so that is done by the push operation. And when we are removing the elements from the stack, that is called as the pop operation, right? Whereas pick and is empty is what in order to check the top of the element and whether the stack is empty or not, so that we are done using a pick and is empty function, right? So hope the stack is quite clear. So the very next thing is, this is how the stack is look like, right? That whenever we are placing one element onto the another element in such a way that the first element is get no at the last, right? And whenever we want to perform the vice versa operation, that is once we push the operation, we want to take out those elements out. So whenever we want to take out the elements out, so whichever elements we have pushed at the end will be get first out. So that is what the LIFO structure for you. And when you're talking about the stack, so there are a number of real-time examples where we use the stack. So as I said, one is the CD, CD stack, which we are using in order to maintain the CDs. Second is what, no, whenever we are going for some function or some, so let's say dinner party or the lunch party. So we are finding that at the buffet table, we are having the stack of the plates, right? So whichever plate we are maintaining at the bottom, that plate will be out at the end, and whichever plate we are pushing at the end will be, first will be that will be the one which will be popped out first. That is what the real-time example for you, where we use the stack. So that particular the stack of plates is basically following the LIFO or a philo structure, that is last in first out or first in last out structure, right? So when you're talking about a stack, the first thing that should be come into the mind, that stack always follows the LIFO structure or the philo structure, that is last in first out or first in last out. So when you're talking about a stack implementation in Java, so in Java, in order to know apply or implement the stack, so the stack is basically no defined, or the stack class is basically defined in the util package. So whenever we want to apply or whenever we want to implement the stack, we'll be requiring the util package, right? So the hierarchy of the stack class is quite like iterable extent. We are having a collection class. Inside the class collection, we are having a list. So inside the list, we are having a vector, and stack is every time we are no implementing the stack, it is always going to extend the vector class, right? So that is what the syntax for you whenever we want to implement the stack class. That is what class stack is always going to extend the vector class, right? Or the vector, you can say, as an interface, not interface, the class, right? That is a base class. Then the different operations which we carried out onto the stack. So as we said, that stack is one of the predefined class inside the util package. So very first thing that we are going to do is we are going to create the object for the stack, right? And the moment we create the object for the stack, we can use all the predefined methods inside the stack class, and the different operations which we can perform on the stack, that is adding the element, accessing the element, no, removing the element, then searching the element, and no, these are the elements, so these are the operations which we actually carried out onto the stack, right? So very first thing that we are going to look into, that is how the once we thought of creating the stack, so very first thing that will be required in the stack, that is the elements. So whenever we want to push the elements, whenever we want to add the elements into the stack, so for adding the element to the stack, we are having the predefined method inside the stack class, that is the push method, right? And in order to use the push method, very first I'll be requiring the util package. The moment I import the util package, I'll be having a stack class, and the moment I want to use the push function, I have to create the object for the stack. So in this particular example, what I did is I just created the object, that is stack1, and I just call the constructor of the stack in order to initialize the stack class. And the moment I create the object for the stack class, now I can use this push method in order to push the different elements into the stack, right? Second thing is that whenever we are creating the stack, so we can now define the type of stack which we want to create, right? So in this case, I have created the two different objects. So very first object which I created, that is a generalized object in which I haven't specified the type of stack I want to create. Whereas in second case, I have just defined the type of the stack, that I want to create the string stack in which all the elements will be of type string. And for that I created the stack2, and accordingly I try to push the elements into the stack. So using no object of the first stack, that is stack1.push, I try to push 4 Java, Python, like that. And using the second stack object, I just try to push the Python, R language, JavaScript, C#, right? So when I try to print this stack1, stack2, accordingly will get the output, right? So if you understand this definition, or the representation of the stack in two different ways. In the first, I just try to create the generalized one. In the second, I just try to create the stack of the more appropriate data type, that is a string. Likewise, you can have the integer, likewise you can have the double. So it's your choice that what sort of elements you want to insert in the particular stack, right? Then the second type of the second operation which we carried out onto the stack, that is what the accessing the elements. So whenever you want to access, or whenever you want to fetch or retrieve the elements from the stack, or more precisely whenever you want to find out the elements which is at the top of the stack, right? As we see that the place from where the elements are pushed, or the place from where the elements are popped out, that particular place is called as the top, that is the top of the stack, right? Every time we just insert the new element of the stack, the top will be get changed. Every time we pop up the element from the stack, the top will be get changed. So the top is nothing but what? The real, that is the point from where the new element can be inserted, or from the point where the new the existing elements can be removed, right? So this pick method is used in order to access the top of the stack, right? So how I'm going to use it? Again, I'm going to import the package. I'm going to create the object for my stack class. Then I will just going to push certain elements into the stack. And now as I want to get the top of the stack, that where the top of the stack is lying at that particular moment of a time, so I'm going to use the pick function, that is the object.pick. So the moment I use the stack.pick, it is going to tell me the top of the stack. So in this case, the top of the stack is what? The first time I'm pushing the welcome, then I'm pushing the to, then I'm pushing the Java, then I'm pushing the programming, then I'm pushing the class. So likewise, if you just try to find out the stack, so likewise we'll be having a stack, that is the welcome, then to, then Java, then programming, and then class. So if I just talk about the pick, or the top of the stack, so in this case, this class will be the top of the stack, right? So just if I try to print the elements, so the welcome to Java programming class, this is what the content of the stack. And when I'm saying that what is the top of the stack, so the top of the stack I'm going to print by means of the pick method, or using the pick method, that is object.pick method, right? Then the third operation which we can carry out onto the stack, that is removing the existing element from the stack. And whenever I want to remove the existing element from the stack, so we are having the pop method. And again, whenever we want to remove the element, that is again done from the top of the stack, right? So no, I will be just importing the package, I will be calling the class, I'll be creating the object for the class, I'll be putting certain elements into the stack, that is pushing certain elements. And once I push certain elements, now what I want is I want to pop the elements. So whenever I want to pop the elements whichever is the top, that will be get popped up, right? That will be get removed. So in order to remove the elements, I'll be using the pop method, which is the part of stack class. And if I want to access the method inside the class, I am requiring the object. So that is what I'm doing. That is the popped element, that is a stack.pop. So when I execute the stack.pop for the first time, it is going to remove the 20. When I now execute the same, that is stack.pop for the second time, it is going to remove the 30. So initially when I just try to print the stack element, I'll be getting as 10, 50, 30, 20. Whereas at that time the top of the stack was 20. So the moment I use stack.pop, it is going to remove the 20. Then my top will become 30. So the moment I try to execute stack.pop, so it is going to remove the 30. So the revised, if I just try to print the revised stack, so now the elements will be 10, 50, whereas the top of the stack will be 15, right? And when I'm talking about the implementation of the stack using a Java code, so basically, no, we are dealing with the four different types of operation into the stack. As we have discussed, that is what pushing the element, then the popping the element, then no displaying the element, and last is what the searching the element, right? So this is what a complete program, that how can we can exactly implement the complete stack operation using Java. So what I did is I just write the first function, that is a stack push function. As I'm creating the integer type of a stack, so I just mentioned the stack integer, and this stack is nothing but the object for the stack class, right? So using this object, that is have passed inside the function, right? Using this object, I just try to push the elements, that is first time 0, 1, 2, 3, 4. So likewise the elements will be get pushed, that will be the part of my stack, right? Next time what I want is I want to know remove the elements from the stack. So again I have just defined one function, that is static void stack pop. Again I have created the object, and in order to perform the popping operation, again I use the for loop. And for popping the elements from the stack, what I did is I just simply call the stack.pop, right? And once the popping operation is done, I'm just saving that element into the y, that is the variable y. Then when I want to know displaying the top of the stack, so as we know that for uh, displaying the top of the stack, we are having the method, that is the pick method. So that is what the one which I used. I have created one function, that is the pick method, and inside that I pass the stack of type integer and created the object stack. And once I want to display the top of the stack, so I use the stack.pick, and I'm storing the stack of the pip, that is in the element variable, and I'm printing that element variable in order to get the exact location of the top of the stack. Then the last and very important operation which we usually carried out over the stack, that is the searching the element in the stack. As we said that there can be the number of elements which will be reside inside the stack. So whenever I want to find out the particular element from the stack, so for that purpose we are performing the searching operation. So for that purpose what I did is I simply created one method, that is a search method, and inside that again I pass the stack and the object of the stack, and moreover I'm passing the element which I want to search, right? And whenever you want to search the element from the stack, so it is get searched with respect to the position, right? And in order to search the element from the stack, we are having the search method, right? So what I did, stack dot search element which I want to search, right? So the element that position will be get stored inside the position. If position equals to -1, then it will say that the element is not found. And if suppose the position equals to no, this condition is get false, so it is going to display the position at which that particular element is found, right? And finally what I did is I just simply call all these methods inside the main method. So I created the object, that is a stack, and no, I'm just calling this method, that is stack push stack, then stack pop, then stack push stack, stack pip, stack search, and accordingly no, I just executed the program. So that's it regarding the stack, that is the implementation of stack using Java, right? You just try to practice this particular program in order to just understand it more properly, And this is one of the way to implement the stack, right? There can be, you can use the different logic, you can use the different orientation in order to implement these operations, but operations are quite fixed, right? So yes, that's it for the stack. In the next class we are going to see the last implementation of last data structure from this particular syllabus, that is the queue, right? So see you in the next class with the implementation of queue. Thank you so much.